All right, so let's get started. Very good evening to all participants to this, today's edition of the Research and Publications Research Workshop Series. I'm Professor Sandeep Chakrabarti, and on behalf of the Research and Publications Office here at IIMA, I extend my warm welcome. And we are delighted to have Professor Maya Ganesh today with us. Professor Ganesh is an assistant professor at the Indian Institute of Management, Ahmedabad. She is a faculty in the production and quantitative methods area. Professor Ganesh, today, the topic of, as you all know, of this workshop for today is Introduction to Discrete Choice Modeling. So we are going to not only hear from Professor Ganesh about discrete choice modeling, but I'm sure she'll make it interactive, because it's a workshop, not necessarily a research talk. So today, Professor Ganesh is going to introduce theories of individual choice behavior. She's going to talk about, she's going to start with binary choice models. She's going to move on to multinomial models. And she's also going to talk about some of the limitations of a logistic regression model. It's going to be a 2-hour workshop. It is advisable that the participants keep their videos on, the cameras on. As I said, Professor Ganesh is going to run this in an interactive manner. If you have any questions, please feel free to type your question in the chat box. But Professor Ganesh would also prefer, as she has mentioned, if you could raise your hand at any time during this workshop, and she will pause and try to clarify your question. This workshop is going to be recorded, and we typically publish the workshop recording on our YouTube channel. So just so you know. There are no other rules. I think it's over to Professor Ganesh. Over to you.
Thank you. Thank you, Sandeep, for the introduction. Hello, everyone. Thanks for joining in. I mean, especially what with it being a Friday evening and all. So I'm counting on your energy and attention for the next 2 hours or so. So like Professor Sandeep mentioned, I'm Maya Ganesh. I am an assistant professor of operations management at IIM Ahmedabad here. So almost everything that I or you, a person does involves a choice, right? I mean, consciously or subconsciously, we make decisions by comparing alternatives that we have at our disposal, selecting an action which we call a choice outcome. And in recent years, there has been a growing interest in developing and in using quantitative methods and statistical methods to study how people make decisions. And the objective or the goal is to learn more about how decisions are made and to be able to predict how people will make decisions in the future, right? I mean, for instance, why did I choose to conduct this workshop, right? I mean, can it be explained by my innate desire for, say, some personal gain, or is it motivated by some other factor, right? So, and by identifying this cause, in some sense, we are able to uncover the underlying purpose, right? It could be because I'm maximizing my own enjoyment, right? I would like to do this. Or maybe some community-based purpose, for instance, like my obligation to my institution, perhaps, right? And regardless of what the purpose is, it's probable that I made this decision based on a variety of considerations that I have taken into account, right? And one could think of many things in everyday life, right? We could think of binary decisions like, oh, do I need to do an MBA or not do an MBA? Do I need to trade or do I need to not trade? Or even you would have made this decision too, right? I'm like, oh, do I need to register for this workshop or not register? Or even after registering, it's not written in stone. So like, oh, do I attend this workshop or do I not attend this workshop? right? Or we could think of non-binary, move away from binary, and think of every day when you when you're buying, let us say, a breakfast cereal, you're thinking of a brand choice, or the weekend is coming, so you want to watch a movie, so location choice in terms of which theater, etc. Or the Gujarat elections is coming up, so electoral choices in terms of, oh, who should I cast my vote, or even a newspaper or a magazine subscription, or a choice of an insurance provider, right? Examples are galore. Now, while however simple the observed outcome may be to the decision maker, right? As a decision maker, it was obvious, it was simple that you made the choice. But from an analyst's standpoint, for an analyst who is trying to explain this choice outcome through some captured data, and I will never have complete information, right, in order to be able to explain that choice completely. And this becomes a challenge. It becomes even more challenging because we are all different in making these choices, right? If let us say we were all clones, the world of individuals is somehow represented by the single person and everybody same, then the life of an analyst would be very simple, right? I could just elicit a response from one person, and then I could say, oh, this is how the expand it to the population and say this is how they behave, right? But that's not true. Unfortunately, there is a huge amount of variability in reasoning, the underlying decisions made by these population, right? And this variability, this inherent variability, we refer to as heterogeneity, right? And the challenge for the analyst, as an analyst, when we try to explain the behavior, when we try to explain the choice, the challenge is to find ways so that I can, whatever my ways of observing is, I am able to measure this variability, right? And I'm able to minimize the unobserved variability that is there. And that is the main task in front of a choice analyst that is there, right? And so how this interest is driven by what? I mean, why am I doing this? The goal is to be able to more accurately represent why an individual is making a particular choice and how this individual is making trade-offs among the various characteristics or various features of the alternatives, right? So typically, we are interested in the aggregate behavior of a large number of individuals, right, or organizations. It could be such as a market demand, for instance, a market demand for a product or a service, right? And this aggregate behavior is actually a accumulation of the individual decisions, right? And which is why the modeling of an individual behavior is in some sense at the heart of all the predictive models of collective behavior that you typically see, right? You see a lot of demand estimation models which are at an aggregate level. And when we think of a good theory of behavior, there are certain characteristics that we want from this theory, right? One is it has to be descriptive. And what do I mean by that? When I say descriptive, all I mean to say is this theory should explain, right, how human beings behave, but not prescribe, right? It should not tell, oh, this is how to behave. No, that's not the point. They're already behaving in a certain way, and this theory should be able to explain that, right? And when I say it has to be abstract, all I'm saying is that it can't be that it is only to that particular circumstance that I'm able to explain that theory, right? I need to be able to generalize it. I need to be able to abstract out from that circumstance, from that scenario, and still that model should be applicable to any other circumstance that I might later encounter, right? And then it should be operational. And what I mean by that is, in some sense, it should result in models. And what do I mean by model? A model should have a parameter, which I'm trying to estimate. A model should have some variables, right? And which can be measured, and then some parameters which can be estimated. But unfortunately, there is no one widely accepted or one universally accepted theory that meets all of this criteria, right? And alternate theories exist which fundamentally differ in the degree to which they idealize this mental process that generates the observed behavior. So the focus of this workshop is on classical economic consumer and discrete choice theories, which assume the existence of a single objective function called utility. We will talk about it more in the course of the next 2 hours. Loosely put in layman terms, I can say satisfaction, right? Okay, that's what is driving us to take these decisions, right? So for the next 2 hours or so, we will be talking about these multiple theories of individual choice behavior, right? And once we kind of come down to, oh, what is that theory of behavior which is able to kind of explain why human beings are making a choice, we will start slow, we'll start simple, right? We'll just look at binary, where I just have to make a decision where there are just 2 alternatives for me, right? And then we will look at something called a binary logit model, right? We will also briefly discuss what other kind of models are available, why are we discussing the logit model, and if, let us say, what are the assumptions that this logit model make, and if those assumptions are not satisfied, what other options are available to me in terms of modeling. We will briefly discuss that. We'll look at the estimation of the binary logit model, and then we will extend this, right? The same machinery that we would have built, the same mathematical machinery, we will see that, oh, if it is greater than 2, instead of 2 alternatives, if I have more, how can I extend the same machinery into a multinomial choice? So we will look at multinomial logit, and then we will look at some properties of the logit, which will tell us what are the strengths. Okay, are there any weaknesses? Are there any fundamental assumptions that it makes, which can kind of break or give me completely misrepresented or wrong results or conclusions? So we will look at that as well. So what we are after, what we need is a conceptual framework. Right? So we'll mostly use ideas from economics, right? So we will start with the idea that, okay, a person's preferences for specific options are the best way for me to figure out which option they choose, right? So if you ask me, the first step for me is to say, okay, I'm choosing this option. Why am I choosing this? Oh, okay, I have some preferences. So maybe if I can figure that out, maybe if I can go towards what are these person's preferences for these specific options, maybe I can say something about what they're doing, right? And we use the word preference all the time, right? So for instance, I could say, oh, I would rather drive to work than take the bus, right? And if we dig a little deeper and try to find out what this means, we could figure out that, oh, maybe I prefer car to public transportation because I need to get in time, right? Maybe because of travel time, maybe because of comfort, maybe because of convenience. I can start whenever I want, maybe because of safety, right? Or even because of status, perhaps, right? I mean, like maybe the car that I'm driving, maybe it is a status symbol, right? Or it could also be other reasons, right? It could be just because I am somebody who cares a lot about the environment, perhaps, right? I'm like, oh, pollution, global warming, maybe I shouldn't take a car, I should take a public transport, etc. Right? So let's say we are talking about this person, right, who is deciding how do they have mode of transportation, what is the mode in which they'll get to work, right? So either they can drive, or they can take the bus, or maybe walk to work, perhaps, right? So for now, let us just keep things simple. So let us just consider these 3 options. Right? Of course, it's once we do this for these 3 options, it's easy to generalize. We'll see that it's easy to generalize, right? And now let's assume that, okay, I have gone ahead. Let us say I have a lot of spare time at my disposal. Okay, so I have gone ahead, I have spoken to a group of travelers, and I have found out like all the reasons why they choose one of these options, right? Now, again, the list is probably going to be long, but let us say that I have arrived at the 3 top things that they consider, right, as to why they're taking. Let us say they tell me that, okay, the travel time, right, and let us say the travel cost, and let's say comfort, right? Of course, later you will see that, okay, choosing only these three criteria or only these three attributes is perhaps a gross oversimplification of what really drives people's preferences, right? But and in order to get accurate data, we need to measure a large number of attributes, etc. In fact, even travel time, when I think about it, I'm writing it down here as though it's so easy for me to kind of collect data on that. But even this could be a complicated thing, right? For instance, if I ask somebody, what is the travel time that it takes? What's the time that it takes for you to reach? They could say, oh, what do you mean by travel time? I first walk to the bus stop from here, then I wait for the bus to arrive, then there is the travel in the bus itself, right? All of that could be there. Or if you think of a car, they're like, oh, okay, I reach the destination, but then, you know, getting a parking space is not easy. So I spend a lot of time in finding a parking spot for my car, etc. But for now, let us assume that I have been able to collect data on this, right? I have been successful. So what am I saying? I have something like this. Right? And for each of these, let us say let me call this T, let me call this C. Oh, this is also C. So let me just call this O. So some T1, T2, T3, C1, C2, C3. Right? Now, this information is then processed, right? So what are we saying? Okay, for the decision maker, actually all of this information is available, and then using this information, that commuter or that passenger or that decision maker arrives at a choice of travel mode, right? And again, it's not, this information is not enough, right? On top of this information, I need to apply something called a decision rule. If you just give me this information and say, oh, okay, make the choice, it's not enough, right? I need to be able to select, oh, okay, is travel time more important to me? Okay, maybe I don't care about comfort. I have to reach on time. Punctuality is very important. So that final step is actually involves something called a decision rule. We will talk about it more. Okay. So any choice, right, is an outcome of the sequential decision-making process that we are looking at, right? So definition of the choice problem. So in this case, we are talking about the mode, right? Okay, what is the mode of transport that the person chooses, right? And then there is this generation of the alternatives. So in this case, we said, oh, okay, there is a car, there is a bus, and then I could walk, right? So generation of this alternatives, and then evaluation of the attributes of that alternatives, right? So in this case, what did we choose? We chose that, oh, there are three attributes that are important to the commuter. One is travel time, one is travel cost, and the other is comfort, right? And then we are trying to evaluate the attributes of that alternative. And then, like we said, there is a decision rule that is applied based on which I make the choice. And then there is the implementation of the choice outcome itself. Right. So what we need to, what is worth noting is that not all observed choice behavior is an outcome of such an explicit decision-making process, right? So for instance, you can say, no, I don't do this. I mean, I follow a habit. I'm habituated to doing it. So let's say as a kid, my father always took me to school using a bus. So I don't even have to think about it. Later, when I grew as an adult as well, I was just habituated to it, right? Or you could say, oh no, I am imitating somebody because I consider that person to be an expert, or that person knows more than me, right? For instance, if let us say I relocate to a new neighborhood, and then I am like, oh, okay, I need to get a new internet connection, right? And I don't know there. So I just talk to my neighbor to my left, my neighbor to my right, and they say, oh no, please take Airtel. Airtel is the best, right? So in this case, I am choosing Airtel because I consider that, okay, they know, these people in the neighborhood know better than me. But even these forms of behavior, the examples that I gave you just now, can be represented as a choice process in which the decision maker has generated only one alternative, right? Because I have not even considered any other alternative in this case. Airtel is the only alternative that I considered. Or taking the bus in the example that I gave you, where my father took me to school in bus as a child, is the only alternative that I have generated, right? So that can also be represented as a choice process technically. Right. So based on this, based on what we have discussed till now, we can define the elements that are involved in a choice process. Let me just quickly look at the chat box. Okay, I want to see. We were talking about elements involved in a choice process, right? So one, of course, is the decision maker. Right. And so this is, when we say decision maker, we are actually talking in terms of unit of decision making, right? So it need not always be a single person, right? For instance, it could be a household. Right. If, for instance, I'm buying, we have to buy a car, right? It is not just my decision. It is all the members in my family. I'll consult my sister, I'll consult my father, I'll consult my mother, etc. Right. So the unit of decision making need not always be a single person. It could be a household or a family. Right. It could also be an organization or a firm. Right. For instance, if I am let's say original equipment manufacturer, right, a two-wheeler manufacturer, I want to decide who should I give this contract of supplier to, right? I'm making a choice of suppliers, for instance, right? So there again, it could, the level of decision making is different, which is why we call that as a decision maker. It need not be a person. It could be an organization. It could be a family, etc. Right. And the other thing which I alluded to during the in the beginning of my in the beginning of this talk is that we need to be cognizant about the fact that there is variability, there is heterogeneity, right? People make choices in different ways and they have different tastes. The second element is the alternatives themselves. Right? Any choice is, by definition, consists of a non-empty set of alternatives, right? By definition, because there should at least be one for me to even be able to make that decision, right? And the environment of the decision maker, it decides what are all the alternatives that are available to me, right? And we call that universal set of alternatives. And as a decision maker, for any single decision maker, what I typically have is a subset of this universal set, which we call as the choice set. Right. And what do I mean by this? So this choice set typically includes those alternatives that are feasible to the decision maker during the decision making process, right? Like, for instance, let us say when I'm thinking of this mode, right? Let us use the same example. So maybe I live in the outskirts of the area of the city, where there is the bus service does not extend till there, right? So in that case, the universal set includes the bus as an option, but in the choice set, when I am making, this alternative is not feasible to me, right? Or for instance, maybe I'm doing an internship and I'm living on a small stipend, so which means that I have constraints on monetary resources. So taking a cab or buying a car is completely out of question. So in that case, that alternative will not be in my choice set, right? So it could be for the constraints could be physical, the constraints could be monetary, or the constraints could even be information, right? For instance, it's been long since I have left my hometown of Bangalore, right? So I don't even know how the metro operates. The metro now operates. I don't know where all are the stations, etc. So it could, the constraint could also be in terms of information, right? So which is why the choice set is always typically a subset of this universal set, right? Now, the other interesting and useful distinction that we make in terms of the choice sets themselves is what we call as continuous choice sets and discrete choice sets, right? So what do I mean by continuous choice sets? This is the in your microeconomic theory, what would you would have learned about commodity bundles, etc., right? Right, so that is the basis for your classical microeconomic demand analysis and all of that. So for instance, I mean, the example that you would have obviously seen is that of bread and milk, right? So if, let us say, I want to buy, my commodity bundle consists of, let us say, rice and some, let's say, moong dal and some veggies. So I will decide, okay, how much quantity of rice, how much quantity of dal, and how much quantity of veggies to buy, right? So in this case, I would think of it as so these are the three quantities, right? And there will be prices associated with it. So let us say P1, P2, P3 are the prices associated with it, right? And usually how do we represent? Okay, I have some constraint on, oh, this is all the money that I have. So there is a budget constraint, there is an income constraint. So I will buy, so I'll spend something on rice, I'll spend something on dal, and then I'll spend this on Q3, and this has to be less than whatever income that I have, right? This is the budget constraint. The second kind of choice set is the discontinuous choice set, right? So for instance, if I am thinking of as a household, let us say we want to buy a car, and let us say there are three car brands in my choice set, right? Maybe Maruti, Tata, and Hyundai, right? So in this case, the choice set is simply the set of three discrete points, right? Tata, what did I say? Maruti and Hyundai, right? Let's see, I think there is a... Yes, I will come to that. We will call it discontinuous. I'll come to discrete. Vikas, is it? Yeah. Okay, so let's call it discontinuous for now. We will make the definition of discrete much more sharper in a while. Okay. The third element that I could think of is the attributes of these. Yeah, Dibyendu.
You just told that, okay, in the first case, when we are talking about the continuous thing, we took rice, dal, and the veggies, and that three different price points, P1, P2, and P3, and the volumes like V1, V2, and P3, whatever it's like, or the quantities, and we are buying it together. Isn't that being over there, if I only look at buying rice or buying dal or buying the veggies, would it not be a discrete or a discontinuous choice?
Yes, that is the corner point solution, right? Or like you're not buying anything. So in that, it's yes, certainly. But it lets you, right? Because of the nature of the product, it lets you also buy a continuous kind of the bundle that we are talking about. But in the other example that I gave, in the Tata, Maruti, Hyundai, by nature of the choice itself, the choice set itself, it cannot be continuous. It has to be those corner points.
Normally, we do not buy two cars. That's right. Yeah.
Yes.
Yeah.
Yeah. Okay, so the third element is the attributes of the alternatives themselves, right? So the value of an attribute is based on how attractive it is, right? And the scale could be ordinal in terms of, oh, Tata is the fastest car, or Hyundai is the second fastest car, and then Maruti is the slowest car. It could be ordinal, or it could be cardinal in the sense that I can say that, oh, this costs whatever 2 lakhs so much rupees. I don't know what, that's very low, right? Whatever lakhs that is. Or the second one could cost some INR, in which case it is cardinal, right? It could be represented in that. Now, I want to make a point here. I want you guys to note one thing, that here at this point in time, we are not making a differentiation between certainty and possible results, right? Like for instance, when I say that, okay, what is the amount of time that it takes for a person to get from one place to the other, let us say, right? Because I said travel time, I took one of the attributes or one of the characteristics is travel time. Now, of course, if you go and ask somebody, they might say, oh, okay, on some days it's not congested, etc. So it will take me 20 minutes. On some days the traffic kind of piles up, so it takes me 21 minutes, right? So they might say that, okay, it varies between 20 minutes to, let us say, 24 minutes, right? So the way here when we model, we still take it as a certain outcome. So, okay, maybe an expected, maybe an average time, oh, it takes you 22 minutes, but it's not that this feature cannot be implemented here, right? We could think of the difference in the travel time as an additional attribute, right? I can say, okay, along with the travel time, I'll have another attribute which I'm calling the variance in travel time, for instance, right? So we could have an additional attribute and we could kind of operationalize that, right? Because many a times you wouldn't know, like for instance, the performance of a car, right? When you want to take that into consideration before you buy a car, the performance can only be over time, you can judge that, but you would have a notion of an expectation, an expected performance that a car might give, right? Then the fourth element is the decision rule. Let me actually write this in the next slide. Dibyendu, do you have a question?
You were saying the travel time. Yeah, it might be the road conditions. It might be something else, the traffic on the road, which might be, the reasons for which the travel time might be different, on different days that we look at. So when you were saying that, okay, on an average travel time, and if I have a kind of a data, which is like for a certain period of time, maybe for 3 months or 4 months or 6 months, I can have the data and can have a kind of an average time, and can also look at what is the kind of deviations or the standard deviations that I have got. And if I can actually have that kind of a distribution, if I can, have a kind of a theoretical distribution built into it, so that I can actually model that thing in terms of a distribution, then probably it would be also working in this discrete choice modeling. I can build that thing also over here.
Yes, but you will have to operationalize it as a variable. You'll have to define it, right? Like when we said, okay, variance, we said that, okay, some notion of variance, or maybe maximum and minimum. From the distribution, you can get a maximum, you can get a minimum, you can get the mean, you can get the dispersion, right? But you will have to define these as variables. You can, of course, use all that information, define those as variables, and put that as the attributes for the alternatives that we are talking about. You could certainly do that.
Thank you.
Right. So the fourth element that we are talking about is the decision rule itself, right? Because we said, okay, there is this choice alternatives. I have told you what are the alternatives. I have told you what are the attributes, etc. But then after I have that, remember the table that I had, okay, time, this is the time that it takes for these 3 modes. This is the cost for these 3 modes, right? And this is the comfort level for these 3 modes. After I have that data, I should I should have a decision rule for me to be able to make that choice, right? So there are a couple of decision rules available for us. We will look at what is the best for us to be able to model this, but we will also discuss briefly what are the kind of decision rules that are available to us, right? So when I say dominance, all that I am saying is that, okay, when compared to another choice, one choice is said to be dominant if it is better in at least one way and it is not worse in any way, right? So what am I saying? For example, if I am in the mode choice that we said there are three choices, right? We said there is bus, we said there is car, and we said you can walk. Now let us say think that as though there is another public transportation option available. Let's say a metro. Right now, if this metro choice, let us say, has the same price and the same level of comfort as the bus, but it takes longer to get there, right? Then in some sense, you can actually knock off this from your choice set, because you're saying that, oh, okay, this subway has the same, or this metro has the same price as the bus. It has the same level of comfort, but it is taking longer than the bus, right? So that is, if you're using the decision rule of dominance, then that is what you're doing. But again, the way in the example that I gave just now, you could easily see that it doesn't always result in a unique choice, right? At best, what it can do, this rule can be used to get rid of some of the options, right? It will not always help you arrive at a unique choice. The other kind of...
Ma'am, sorry, I am interrupting. I'm sorry to interrupt you at this point. Now, you just said, okay, there are several kind of variables that we are dealing with, okay, when we are making a choice over there. And we're saying that, okay, a car is a choice, or a bus is a choice, or might be the metro, or any, I can work down there. So these are the choices. And I have got, the three different things that we have taken as your travel cost, travel time, and maybe, the other kind of convenience or whatever it has been taken. So over there, when a person is probably, every person is different. And when we are looking at a collective, kind of a decision making, that what you are saying, maybe in the context of an organization or somewhere, or maybe in a household, it's like that the relative importance that I assign to each of this, maybe to the travel time or the travel cost or the convenience, would be different for the different people that they would be assigning to that.
Let me stop you there, Divyendra. Just hold on for 5 minutes. We'll get to what you're saying, right? Yeah. I'm kind of taking you through various decision rules that are available, and finally, when we settle on one, it should perhaps answer your question. So, could you hold on for like about 5?
Sure.
And sorry, if it's not answered, we could take your question. Okay.
Yeah, sure.
I'm building to that. I'm building to what you're saying, right? A decision rule which can incorporate most of the features that you kind of expressed. Okay, so there is one more kind of decision making or decision rule, which we call as satisfaction, right? Where we say that, okay, there is a level of threshold, or there is a level of aspiration where I'm saying that, okay, I have to get to office at 9 o'clock and I can't leave earlier than 8, which means that if that takes more than 60 minutes or more than 1 hour, I'll not even look at that option. Or this is all the money that I have, and the money that I can afford to spend in transportation this is all, which means 100 rupees per day, let us say. So anything greater than 100 rupees, I will not even be able to look at that choice, right? So in some sense, I am setting upper limits or lower limits depending on what the criteria is, and then I will knock off the other choices. And again, just like we mentioned in dominance, this also can only help you kind of knock off some criteria, but not really help you arrive at a single unique choice, right? Or like Divyendra was saying, one could think of a lexicographic rule where I'm saying that, okay, travel time, cost, and comfort are there, but then maybe I can rank these 3 attributes on how important they are to me, right? Okay, I am a student, I am an intern traveling. Comfort, what comfort am I talking about? It's not even important to me. I can make do if I have to stand and go, etc. Right? So I can rank those attributes and then say, oh, okay, travel time is the most important for me, right? I have to be there on time, and then look at, oh, these are the 3 options that I have, of which gives me the least time, right? Or if there's a tie, then I could say, okay, there's a tie here. What is the second important attribute for me? Or maybe then cost, right? And then look at, okay, both of them are equally time wise, they are equal, but then can I look at the next rule, etc. Right? But here again, you could think that it is easy to kind of get rid of alternatives, but again, to arrive at a particular choice, it should be in combination with all of the other rules that we mentioned, right? The other decision rule that we typically talk about, which you would have also heard about, is something called utility, right? And what am I saying here? Okay, it's based on this idea that all the attributes that I kind of listed, right, they're all comparable, which means, what am I saying? That somehow the attractiveness of one option, right, can be, which is shown through the value of its attributes, can be reduced to a single number. Right? So somehow I'm saying that all of this, the attractiveness of this option, which is shown by all of these attributes, travel cost, travel time, comfort, etc., all of that can be reduced to a single number, right? In that case, what does it allow me to do? I can then set up a single objective function which shows how appealing an option is based on all of these attributes or based on these features, right? And this number, right, or this measure of how attractive an option is, we call this as utility, right? We will use this term from now on. So in some sense, this is so the objective function can be defined as, I'm maximizing the utility, right? So where am I getting the most utility from? Which choice is giving me the most utility, right? So the existence of this single index or the single number is based on the notion of trade-offs, right? And this is what we will come to that. We will mathematically put that as well. But it kind of refers to what Dibyendu was saying earlier, which is that, okay, all of these attributes are not equally important to me. Can I assign some weightages to all of this so that I can arrive at this number, right? Arrive at this one single number for what is the utility that this option is giving to me? What is the utility that the second option or alternative is giving to me? What is the utility that this third option or alternative is giving to me? Is that okay? Are there any questions here? So if I come back to the mode choice example, and if I go back to the table that I was writing, so all I'm able to do is arrive at these three numbers, right? For car, for bus, and for walking. Right? And then I will say that, oh, okay, whichever is giving me the highest utility of these, that is the mode choice that I am making. Right?
Ma'am, one question. So if we remove some of the constraints by using, let's suppose, dominant strategy, then do we really need the second decision rule, that is the satisfaction level? So for instance,
so what do you mean by when you need? So these are all so researchers over time have come up with, so go back to what I was telling at the beginning, right? So we are not prescribing, we are not telling the decision maker how to make a decision. The decision maker is making that decision, and we are observing, and we are trying to see what is the best way in which I can predict their choice, or I can explain that choice or behavior. Right? So these are various rules which people tried to explain but could not completely explain the choice. And this is the fourth one, the final one that I described, is at least now accepted as, okay, something that can be explained. We will talk about how to model this mathematically, what part can be explained, how do I put the part which I cannot explain, how do I describe that, etc. We'll come to that.
Okay. So the decision maker would be using only one of the rule while making a decision. So it cannot be combination of two rules, like, or am I missing out something?
No, he could. Like, for instance, what did we say? We said that, okay, dominance and satisfaction can be used to knock off some variable, knock off some alternatives, right? So maybe in reality, to come up to that choice set from the universal set, the decision maker is actually using all of this and coming to his or her choice set based on this.
Right. So that's what I'm saying. So if the decision maker knock off some of the variables using dominant strategy, like dominance decision rule, then does he really need that satisfaction thing, because if let's suppose if I'm knocking off anything which is worse than
yeah, so the point I'm making is that all of this is not simultaneously necessary. I'm just alternative ways
right
could use. Okay, so it's not necessary that they'll use this and this and this and come to this. No.
Okay.
Is there any other question? Let me look at the chat box. Suresh is asking me, does utility needs to be a real number? Okay, that brings me to the note that I was about to say. So yes, utility is a number here, but then remember that the absolute value of this utility actually does not, we don't care about it. We are indifferent to it. Why? Because only their ordering matters to us, right? The level of the utility is immaterial because I can always add a constant, right? For instance, in the car, bus and walking example, I could have utility values like 100, 200, 300, or I could have 10, 20, and 30. All I care about is which is giving me the greatest utility here, right? So all I care is about the ordering of that. So it is a number, but the absolute values really do not matter to us, right? You could always add a constant to it and it will just shift what it is. It will just shift this thing, but the scale of the utility does not really matter to us. It's the ordering that matters, right? It's the ordinal notion of utility. Yes, Dibyendu, it is relative in the sense that we are ordering it based on the value that it has. Okay. So in the last 5 to 10 minutes, what did we discuss? We spoke about the various elements, right? Various elements of this choice process. We looked at the decision maker. We spoke about units of decision making and how taste preferences could be different in a population of individuals. We looked at alternatives and we said, oh, there could be a universal set, and a subset of that is the choice set, which typically is at the disposal of a decision maker. We looked at the attributes of alternatives, right? In this case, we very naively took only 3 attributes, but then we realized, we are cognizant of the fact that there could be many attributes. And then we looked at different decision-making rules. Okay? One more point before we go on. So you would have already seen this in economics, in your microeconomics as well, that when we say a decision maker, we always assume that the decision maker is rational, right? And what do we mean when we say the decision maker is rational? We mean that the decision maker is consistent. And what do we mean by consistent? Which means that given the same set of alternatives, attributes, and the level or the value of the attributes, the person will make the same choice again and again, right? So if I say it takes you 10 rupees to go by bus, it takes you whatever 20 minutes and this, and for walk it takes you 30 minutes and whatever 2 rupees. And so if I give you these values, and let us say based on these values you make a choice, you are consistent that the next time I present you with the same scenario in the same situation, you will make the same decision, right? So in some sense you can think of it as the opposite of impulsiveness, right? And this is how we are defining a rational decision maker here. Okay. And what do we mean by the rational decision maker is transitive, which means that if I prefer mode 1 to mode 2, and I prefer mode 1 to mode 3 again, then I know that I prefer mode 1 to mode 3, right? So very simply put, if I say that, okay, I know that as a person, let us say, I like chocolates over gulab jamun, right? If you tell me, do you want gulab jamun or chocolate? I'll say, okay, I want chocolate. And if I prefer ice cream over chocolate, then when you present to me gulab jamun and an ice cream, I always prefer an ice cream, right? So this transitivity of preferences is preserved, right? So when we assume here that it's a rational decision maker who is making a rational decision in terms of choosing whichever gives him or her the maximum utility, we are also saying that the decision maker is in some sense both consistent and transitive in his or her behavior. So now when we come, so now we have defined what are the elements, right? Now our next challenge or next step is to be able to put all of this in some mathematical theory, to be able to put all of this in a succinct manner, right? So the objective is to provide the means for transformation of all of these assumptions that we spoke about the attributes into a demand function. Right. So if we just before going to the discrete, so if we think about what we spoke about in terms of the consumption bundle, so all we are saying is that, okay, there is a bundle in which the consumer can choose Q1, Q2, Q3 in the example that we gave, rice, dal, and vegetables, but it could also, there could be many other quantities that I could think of. There could be many other products in the bundle that I could think of, right? And all I am saying is that this, when I'm buying all of this Pi, Qi, where I is going from 1 to L is less than or equal to I, right? So this is your classical economic theory. Now, in the classical economic theory, there is no, you don't explicit, there's no explicit treatment of attributes, right? In addition to the to these quantities that we described as an alternate. So what would, you would have multiple bundles, right? You could buy 2 kgs of rice, 1 kg of dal, and half a kilo of veggies. Or you could buy, I don't know, half a kilo of rice, 2 kgs of dal, and 1 kg of veggies, right? So based on that constraint of income, you could have multiple bundles, right? So you would have multiple alternative bundles, and let us say, let's call, so if I call Qi as one bundle, you will buy or you will choose this bundle Qi only if you prefer this bundle over, let us say, some other bundle Qj. And again here, remember that rational behavior is being continued, transitivity is being continued, etc. So if we can define a utility for all of these, right, for all of these bundles, all I am saying is that if if the consumer chooses bundle I, which means that this bundle I, or the utility that the consumer gets from this bundle I, is greater than the utility that the consumer gets from bundle J. Right? Of course, this is assuming that it satisfies the budget constraint already. Right? And then what do you typically do? You would have seen that there is some utility function or some functional form that is given. So for instance, if we look at, let us say, 2 quantities, let us say if I'm only looking at rice and dal here, I'll have some utility function, let us say like this, right? Where these are the taste parameters, right? And then, of course, this is subject to the constraint of your income constraint. Okay. And then what do you do? If it's a continuous function, you can easily use any of your calculus, right? You can easily use your Lagrangian methods and your Lagrangian functions, and you can differentiate, you can get the first order conditions, etc. And you can define, you can actually arrive at, if as a customer, if I'm solving, I know my tastes and preferences, so I can solve for Q1 and Q2 and find what is that quantity that maximizes my utility for this function that I have defined, right? Now, this classical economic theory, what does it assume? So in this case, the preferences are implicit in the form, right? So when I wrote beta 1, beta 2 in that utility form, they're implicit in the form and the parameter values of the utility function, right? Now, in empirical applications, when I am observing this choice and when I'm trying to find out what it is there, so it's crucial for me to define how preferences and consequently how utility functions are chosen for these customers, right? And then that is where we bring in socioeconomic characteristics, because we said, oh, these preferences could be different for different people, right? So it depends on my characteristics, it could depend on socioeconomic characteristics, etc. So when we talk about discrete choice theory, right, it is derived from the same concepts, right, that we just now described, right? It is still the notion of a rational consumer, etc. But the only difference is that there is a discrete representation of the set of alternatives, right? Go back to my example. Instead of rice, dal, and vegetables, we have Maruti, Hyundai, and Tata. And why is this distinction different? I mean, am I just being pedantic? Okay, continuous, and this is discrete. Am I just being pedantic? No. The challenge is that in your continuous realm, you could use all your calculus principles, right? You could use calculus happily to derive your demand functions and all of that. But the moment one or more commodities can be zero, right? In the example that earlier Dibyendu had given, the maximization problem actually becomes a corner solution, right? Where your usual first order conditions for an optima and all do not hold, right? So what is actually happening in this case? So if I have to use the same representation, right, same machinery, and kind of see what is happening is that it is still true, right? It is still true that I am getting utility from these three Maruti, Hyundai, and Tata. But what am I saying here? I'm saying that this Q1 can only take the values 1 or 0, right? So if this mode 1 is chosen, I'm saying it takes the value 1 and 0 otherwise. And similarly, I'm defining Q2 and Q3. Right? And only one alternative is chosen, which means what? My Q1, Q2, Q2, Q3, and Q1, Q3 should actually be 0. Right? Only one of them can be 1, and the other two options have to be 0. Okay. So in the language of the corner solutions that we saw, it would typically be either 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? And this makes it harder, right? So these corner solutions, which are kinks, so it's not differentiable with respect to these quantities, right? Which is why otherwise, if there were no difference in this way of estimation, then we wouldn't need a different theory, right? We wouldn't need a different machinery to model this, because we move away from the continuous realm and we cannot use the calculus machinery. We are trying to kind of develop what machinery can be used when we are in the context of the discrete choice scenario. Right? So it's not possible to use the maximization techniques of calculus to derive your demand functions and all of that, right? So we can still, we can still use utility and we can still define, but we will see where is it that the difference arises. So we can still say that the utility from the first choice or the first alternative is a function of T1, that is the time that it takes, the time that the mode 1 takes, the cost that the mode 1 costs, and the comfort that the mode 1 offers, right? And I can say U2 is a function of, and U3 is a function of T3, C3, and O3. Right? So I can express utility in terms of the attributes of the alternatives, right? And when would I choose, for instance, when would I choose alternative 1? I would choose alternative 1 when it is greater than alternative 2, when the utility that I'm getting is greater than that, and it's also greater than the utility that I'm getting from the third choice, right? A side point, of course, there could be mathematically, there could be that, okay, what if there is a tie, right? Okay, what if U1 is equal to U2 and there is a indifference between two things, etc. So we'll later resolve this problem, but essentially we assume that there is no possibility of a tie, and if there is a possibility of a tie, it is broken randomly and it's kind of ignored in this. So for now, when we think about it, you can think of it as I choose U1 when the utility that I get is greater than the utility from U2 and greater than the utility from U3. Now, what is the next challenge in front of us, or the next step for us is to make assumptions about the form of the utility function. right? And there could be other things just in your conventional regression setup, but the most often assumed for, again, for convenience, is an additive utility function. So you could say something like, okay, beta 1 T1 plus beta 2 C2 plus beta 3, oh sorry, this is 1 again, right? O1. And then U2 would be beta 1 T2 plus beta 2 C2 plus beta 3 O2. Right? So these beta 1, beta 2, and beta 3 are the parameters. Right? Taste parameters. Right? And what is the application of this theory is to be able to predict how it will change. So why are we doing all of this, right? I mean, why are we interested in all of this? In the beginning, I told you that, okay, we need to be able to explain choice behavior. Why do we need to explain? So let us say these are the preferences, right? So let us say this is the beta 1 is the preference that is given to time, right? So let us say as the mayor of the city, for instance, I want to see if I can somehow increase the or somehow decrease the travel time, right? So maybe I can increase bus frequency. I don't know, I can build a flyover, whatever. So maybe somehow I can decrease this time traveled, right? So I want to know that if I decrease the time travel, so let us say by 1 minute or by 2 minutes, what is it? So what is the change in utility that it is giving the consumer, and how will it affect the ordering, right? Because remember, all of this is only ordering, right? So we will later come to the notion of probability, but for now what I'm saying is, how will it increase the utility of this such that if it is greater than the other one, will it kind of come above the other, right? So this is the reason why we are interested in these betas, right? So if I have, let us say, I was telling you, right, if I have collected data on all of these T's, C's, and O's, that is the comfort, time, and cost, then I can actually use that, go ahead, and I can estimate these taste parameters of the consumer. Now, fine, this is fine. The utility framework is fine. But then when researchers actually tried to use this, right, use this utility framework in most of the experiments, they found that, okay, individuals have not selected the same alternative when there is the same choice situation, right? In repetitions of the same choice situation, the individuals or decision makers have not selected. But we already made the assumption that, okay, it is a rational consumer. So which means that they observed that there were violations of these transitive preference assumptions that we made, etc. Right? So which is why they came up with a probabilistic mechanism, right? Probabilistic choice mechanism, which is capable of capturing these behavior inconsistencies, right? Now, again, I want to mention that this has nothing to do with the inconsistency of the consumer or the decision maker, right? It is actually the it's the analyst's inability, because I don't have the precise information. So maybe there is some unobserved attribute which I don't know what it is and I have not captured, which is why I see that in the same scenario, which I think is the same scenario, because I have some other information which I am unable to observe as an analyst, I am unable to do this, right? I am unable to observe that behavior. So it's, in some sense, it is my admission of a lack of, as an analyst, my admission of a lack of more precise knowledge about the individual's decision-making process, right? So that is creating this. So this probabilistic mechanism that they came up with is to be able to capture the effects of that unobserved variations among the decision makers, or the unobserved attributes of the alternatives, which I as a analyst is unable to see or unable to measure. And Random utility theory is one such probabilistic mechanism which gives us an approach to introduce, right, to introduce this probabilistic choice mechanism. So this was first developed or formalized by a researcher or a scientist called Mansky, in the 1970s, right? So again, I want to reiterate that these observed inconsistencies in the choice behavior of a decision maker is because of the observational deficiencies on the part of the analyst. Right, the individual is always assumed to select the alternate with the highest utility, behave in the rational way that we assume him or her to behave, etc. Right, but the utilities are not known to the analyst with certainty, and therefore the analyst treats that as random variables. Right? Yeah, Anshuman. Yeah, Anshuman.
Hello, am I audible? Hello, ma'am, am I audible?
Yes, yes.
Ma'am, so since you're saying that the failure to calculate the final utility accurately, it's an observational deficiency. So is it the same thing as the standard error in regression? I'm trying to understand how this is different from a regression model.
Yeah, it is like your error component, right? So when you're trying to explain, okay, how much yield will you get based on rainfall, soil, etc., there are some observations you can't, so which is why you put it as an error. So similarly, the idea is similar to that.
Right. So suppose instead of 3, if we had like n number of utilities, n number of choices, and we have n utilities. So basically, we are just trying to calculate the u based on some input variables, which are x1, x2, and x3. And the error that we are, and the error in the final choice is actually coming from the inability to calculate the utility exactly, and that is again as a result of a standard error. So it is similar to regression.
The idea is similar, yes.
Okay.
You will later see that the challenge arises when we try to describe that error. So in regression setup, what do? You assume that error is equally distributed,
normal, right?
etc. So we will see those challenges as to why not all of it follows through and why we need to make different assumptions about the distribution of the error.
Okay.
But it's right in the notion of it. That's the same idea.
Okay, thank you.
Okay. Right. So what are we trying to say? We are trying to say that, okay, probability that a consumer chooses this alternative I, so this is a choice set for consumer N, Cn, and this is the choice I. Right, or alternative I, if you might, right? So this is nothing but the probability that this consumer, the utility that this consumer gets, is greater than UJN, right? For all J belongs to Cn, right? Except I, right? All the other values that it takes. Right, so this is what. So we are coming. We are introducing the notion of probability. We will see why we are introducing that notion of probability. Right. So which means, what are we saying? That these, like I mentioned, these discrepancies are because of the analyst's inadequate observing skills. Right. So it is assumed that the individual always chooses the choice with the maximum utility, but because I don't have all information, I have incomplete information, I treat them as random variables. And there are several sources of this randomness, right? One is unobserved utilities, unobserved attributes itself, right? For instance, in the mode choice example, right? Maybe environmental consciousness or status factor, right? So that could be an attribute which I don't measure at all, which I don't observe at all, right? So it could be because of that, or it could be because of unobserved taste variations, right? For instance, between different individuals, or it could be measurement errors, right? For instance, I don't know. So unobserved taste variations in this sense, let me give an example. For instance, if we look at safety as a characteristic, right? Safety as an attribute, if you think about it. So maybe safety as an attribute is more important, perhaps for a woman traveler, and they give higher preference for this parameter than, say, men, right? So there are these unobserved variations in taste itself. And then there could be measurement errors, right? For instance, when I'm measuring, let us say, time, right? We said that, oh, what is the time that they spend in traveling? Maybe I don't know the exact time that they spend traveling. All I can do is observe, stand at the metro station and kind of observe when they come and when they take the train. So I am kind of using a proxy, right? So we use proxies all the time. For instance, if I want to, let us say, include the intelligence as a variable, I use IQ score as a proxy. Or for instance, these days, if you want to include development, right? Okay, is this part of the city more developed than the other part of the city? We use the night lights data, right? We use intensity in night lights, and we say that, okay, higher the intensity, which means higher, more developed the area is, or the cities, right? So we use proxies all the time, and this could result in measurement errors. Yes, Dibyendu.
At any given point of time, how many, whatever the number of attributes that you choose in terms of explaining the utility over there, there will be always some error that we will be actually making in the process, because it's impossible to actually, include all that probably which is influencing, the choice. Maybe that we have taken some of them into our consideration.
Exactly. That's the point that I'm making, that we will never be able to, as an analyst, observe everything to be able to explain that behavior. And there will always be some lingering randomness because of this multitude of reasons. That's the exact point that I'm trying to make. Right? So this is the reason we express this random utility as two components, right? One is the observable component, or what we call as the systematic component, and the other is the unobservable component. Right? We call this error, or we call this disturbances. Okay? So that utility which we started off with, we are now breaking it down into two components. One is the observable component and the other is the unobservable component, right? So which means I can also write this. I can say that the probability that a customer N chooses this I, right, when given a choice set. So remember, this is the choice set for consumer N, and this is the alternative I. Right? Only when this combined utility, right, which is the observable part and the unobservable part included, when this combined utility is greater than or equal to the combined utility from option J for all such J's in the choice set. Okay. So very quick recap of what we did. So what did we do? We kind of looked at the concept of a decision maker, right? And we again said that this decision maker can be at any level. It can be a person, it can be a household organization. This decision maker was faced with a set of feasible discrete alternatives, right? And the decision maker selects one that yields the greatest utility, right? We also saw that from the perspective of a analyst, we don't always observe completely, which is where we brought in the concept of this randomness. And then we said, okay, this probabilistic theory lets us break down the utility into an observable component and into a unobservable component, which we called as the error or the disturbance, right? Now, so now that we have this machinery, let us see if we can actually define that model. And in order to do that, let us actually take a simple case to begin with, where that choice set Cn consists exactly of two alternatives, right? So I have only alternative J. Let me just see the chat box. I think somebody has a question. Okay, Sandeepan. Okay, I think it was just a comment and perhaps not a question. Okay, so let us look at a simple case where the choice set includes only two alternatives, right? And what is happening in this case? The probability of a person N choosing alternative I will be probability of choosing I will be only if the utility from I, from choice I, is greater than or equal to utility from J. Right? Now, because we have only two alternatives, this probability. So if I can define P and I can easily define P and J as 1 minus PIN, right? Because the probability should sum up to 1. So the moment I have only 2 alternatives, I can easily define P and I, and I can define P and J. Okay, so seems like they're all having some conversation, huh? Okay. Okay. So what did we do? We said that, okay, we were able to partition that, right? So we begin by partitioning the it into 3 steps. One is the separation of the total utility into deterministic and random components, which we just now saw, right? We are there. Now, what is the next challenge in front of it? We have to somehow specify that deterministic component or the observable component, right? Or the systematic component. And we have to specify the random component, right, or the disturbance or the error. So if we do that, then I think we are kind of sorted, right? We'll be confident about, okay, what to do next. So this is what we did already. We said that the utility from alternative I to customer N is the deterministic utility or the observable utility or the systematic utility, and the utility from the disturbances which the analyst cannot observe, right? Now this epsilon in and epsilon jn are the random components or the disturbances, right? I think I already mentioned this, right? I already spoke about how utility is ordinal and not cardinal. So I wanted to make that point again. So now how do we specify the systematic component, right? We have already kind of seen that, isn't it? So what type of variables can enter these functions? So it could either be individual specific variables, right? For instance, whether I will take a bus or I will walk, I'll take a car, depends on what I'm earning, right? I said I'm an intern, I'm on a tight budget, etc., right? So it depends. It could depend on individual kind of variables, right? Or it could be an alternate specific variable, right? Like for instance, the time, the cost that we said, right? All of those are alternate specific variables. So we define both kind of variables, right? So these are individual specific variables which could drive the decision. We call them as Sn, or this is again a vector, okay? It need not be one. So it could be a vector of attributes, or it could be Zin, where I'm saying that it is alternate specific. So for alternative I, for me, it takes so much time to travel. For alternative J, for nth customer, it takes so much time to travel. For alternative K, for the nth customer, it takes so much time to travel. So the second question for us would be, what is a reasonable functional form for this for that V component, right? For the observable component, right? And if we define the betas as the unknown parameters, we could start off with a linear kind of framework that we have. So I could say this VIN could actually be, let us say, beta 1 x in1 plus beta 2 x in2, and I could define this, right? And I could say VJN is actually beta 1 x in j, right? xjn1 plus beta 2 xjn2, and etc. So again, I want to, most of you I think made that point as well. So just like as in regression analysis, linearity in parameters is not a restrictive assumption, okay? So just like in your linear regression, we could think of a polynomial, we could think of logarithmic, we could think of quadratic, right? We could think of any other real transformation of the attribute. So this linearity is only for convenience that we have taken here, and it is
I got it. Thank you. Yeah.
Hello, about the how we have specification of the observable part, right? So now the next challenge in front of us is the specification of the disturbances, right? So in some sense, it's not necessary that we need to talk about, so it's actually the distribution of all of that, right? Of all the errors. But in this case, because it's only a binary, that's only two choices, we can actually think in terms of the differences, right? Of the epsilon jn and the epsilon in. So we can think in terms of how do we specify the appropriate distribution for these, right? So basically what is happening is that depending on the assumptions of the distributions for this, of the distributional assumption of the epsilon in minus epsilon jn, this leads to different choice models, right? So just like in the regression framework, your errors are distributed normally with the mu 0, with the means 0 and variance sigma square, right? So similarly, different assumptions about the distribution of this epsilon jn minus epsilon in is what leads to different choice models, right? So one could think that, so the easiest one that one could think of is if this epsilon in minus epsilon jn is uniformly distributed, right? And that leads to something called the linear probability model, but it brings in a lot of challenges in terms of computational difficulties, etc. Then the next natural way to think about it is what if they are normally distributed, right? So if you think of the disturbances as a as a sum of large number of observed but independent components, then by central limit theorem, the distribution of disturbances would tend to normal, right? So if this normal distributional assumption is made, that leads to something called a binary probit model. But though binary probit is intuitively reasonable and it has theoretical grounds for assumption, etc., it has this, I mean, it has this unfortunate property of not having a closed form, right? So if we have to estimate, we need to resort to numerical approximation, simulation techniques, etc. Which is why then the search for a almost probit-like model is what led to something called the binary logit model, right? So the binary logit model arises from the assumption that this difference in the errors is logistically distributed, right? Now, the good part about this is that the logistical distribution approximates the normal distribution quite well, right? And it is also analytically convenient, right? It has a closed form. The only thing is that logistic distribution has a little fatter tails than your typical normal distribution, but then it's a good approximation of normal distribution, right? Let me look at the chat box. So these are the CDF and the PDF, right? So the cumulative distribution function and the, right, of a logistically distributed function. So what we do then is we come back to the notion of probability, right? So what did we say earlier? We said that, okay, Pn of I, a consumer N would choose I only if the probability of the utility from choice I, alternative I, is greater than the utility from alternative J. And now if I use the CDF of the logistic distribution, I will actually get Pn of I as e to the power mu Vin. So in terms of V and E, and now we can. Okay. So this gives me the binary logic model, and we already defined VIN, right? VIN is the observable part. We already defined VIN in terms of the betas. Remember, we said that, okay, we know what are the attributes, and we defined it in terms of parameters and variables. So if I put, so this is again a vector, okay? This beta is again a vector, and these XIN is all of these attributes, right? It's the list of attributes. So if I write that, then I am actually able to, now that I have defined a distributional assumption for my errors, or in this case for the difference in that errors, I can actually arrive at the probability P and I, which is defined using the assumption of the logistic distribution that I just now made. So then what is the final step which is left for me? That I should be able to use this probability, right? And I should be able to infer, because what is my, where am I, what's my final goal? I want to find out what those betas are, right? So I need to be able to infer these parameters. So what I do is I just define an indicator variable, which takes just the value 0 or 1 if the person chooses alternative I, and 0 if the person chooses the alternative J. And we can easily write the likelihood function, right? We can write the likelihood function as the product of all the, for all the people, right? If there are capital N number of consumers, I am actually taking all of their probabilities, and I am kind of writing my likelihood function. And after this, the task just becomes very simpler, right? So just to not forget with all of this rigmarole going on, not to forget the larger picture. So remember, maximum likelihood intuitively is nothing that it's just a method that what does it do? It kind of helps me get to the such values of parameters in such a way that it will maximize my likelihood that the process described by this particular model has produced the data that were actually observed, right? That's all maximum likelihood is actually doing for me. So I can now easily go ahead and write my function, and then I can maximize it using the framework that I already know, right? So I can actually differentiate this, and I'll get how many? I'll actually get how many ever betas are there, right? Which means how many ever attributes are there. So if we had 3 attributes, I'll have 3 betas, beta 1, beta 2, beta 3. So I will accordingly have that many equations, and I can solve for that many betas, right? So I'll have k equations. So I'll have 3 equations in the case that we took as an example, right? And we can show that this likelihood function is actually globally concave, and such that if a first order solution exists, we can show that it is also unique, right? So we can solve for the system of k equations, and we can arrive at the betas that we wanted. Remember, what were the betas? These betas are associated with the attributes. So in this case, it's associated with travel time, it's associated with travel cost, and it is associated with comfort, right? So very quickly, what all did we do? We said, okay, choice is an outcome of sequential decision making, right? And we said that, okay, it has the following, it has a certain number of steps, right? We saw the elements of a decision making. We said, okay, there is a decision maker, there are alternatives, there are attributes, there are decision rules, right? Then we defined rational behavior. We said that, okay, the consumer has to be consistent and transitive, right? Then we used the classical approach to consumer theory, and we saw how that kind of gave birth to discrete choice theory, right? Then we said that, okay, it's useful to partition that utility into a systematic component which is observable, and into a component which is not observable by the analyst, which we called as the disturbance or the error or the random component. Then we used the probabilistic random utility theory to be able to define that, right? Then we said, okay, this deterministic component, I know how to take care of it, and it could be, so we used a linear way of defining it, but we said that, okay, that it could be defined in any other way. And then we saw that, okay, these are the errors, and if I somehow say how these errors are defined, that can lead to multiple multiple models. And then we said, okay, if I assume this difference in error as a logistical distributed distribution, that gives rise to this special case of a logit model, right? And then we saw a binary logit model. And once we had the binary logit model, all we had to do was set up the likelihood function and then maximize that likelihood function so that we'll get a set of equations. And when we solve for those equations, we get our parameters that we are interested in. Okay, let me look at the chat box. Arul, what do you mean by nonlinear data? Okay, looks like Arul is not there. I'll take that question later, maybe when Arul is around. Okay. So now we started off with a binary model, right? All we have to now do is extend it to a more general case where the choice set consists of more than two alternatives, right? For instance, if you are looking to, let us say, travel for a conference to a different city, you could say, okay, I could take air, I could take a flight, or I could take a train, I could take a bus, or I could take a car, etc. Right? So this we already said. So in the general case, so it can consist of more than two alternatives. Then if you look at it, all the machinery actually follows through. So the only thing we need to do is, earlier we had to specify the univariate distribution of this disturbance. Remember, because there were only two choices. So all I had to do was only epsilon jn and epsilon in. So I could easily specify the distribution for these differences. Now the challenge in front of me is to actually specify the joint distribution for these disturbances. Right? And everything else will follow through, because what did we say? We said that if the person has to choose I, it has to be such that the utility from I has to be greater than j. Here again, it's the same thing, except that it is for all j's in the choice set, right? And we can again break this down, break this utility into vi and jn. So any multinomial choice model can actually be derived again from based on the joint distribution, right? Just like we said, oh, if you assume uniform distribution, it leads to some other model. If you assume normal distribution, it leads to a probit model. If you assume logistic distribution, it led us to a binary logic model. Similarly, here again, you can choose multiple specifications for the disturbances, but the probability will follow through. Remember, what was the probability there? It was just the summation of jn and in. But here, because there are many such alternatives, it will just be summation of e to the power vjn. And everything else will follow through, in the sense that you can still have the likelihood function, you can still maximize it in the same way. It's just that as more and more alternatives are there, the likelihood function becomes complex and complex, but you can still solve for the likelihood function. And similarly, you will arrive at the number of equations as many as the number of attributes are there. And it's very straightforward that it actually, so if the moment you make jn as 2, it reduces to your binary logic equation, and you can solve similarly the same machinery that we saw. You can use that. The only difference is that you made a logistic assumption, right? So here we are assuming something called a Gumbel distribution, right? It's also called an extreme value distribution. Right? So whatever we assume, the logistic distribution for in the binary case, it is equivalent to assuming that in the multinomial case, the errors are Gumbel distributed. Right? So it follows through. Whatever is true for two binary logic in a logistical distribution case, the same can be modeled as a Gumbel distribution in the multinomial case.
Ma'am, just a very small question here.
Yeah.
Ma'am, the reason we are for the binary logic case, the reason we are looking at epsilon in minus epsilon jn is that because we are kind of trying to work on the difference between uin and ujn, and in that.
Hold on. So in the binary logic case, also we were interested in epsilon in and epsilon jn because there were only two there, right? Only two alternatives. When I wrote the vin, I could also define them as differences, which is why I defined them as logistical distribution. In the multinomial case, I have to define a joint distribution of all the epsilon in, jn, all of them. right? And this Gumbel distribution is a joint distribution of all the epsilons.
I'm talking about like the reason it's a difference. The reason the minus is there, is it because intuitively somewhere we are doing a u I n minus u j n, and then the v parts are constant. We know about the v parts, so we are just concerned with the epsilon parts.
True, because what we do, we say that that minus that should be greater for
yes,
all.
exactly.
Yeah, that's
okay.
But it is equivalent to assuming a joint distribution as well. It's only for ease of calculations that we take the difference, but it's equivalent to assuming the joint distribution of all the epsilons.
Okay. Thank you.
Right. So this is the only difference when it comes to multinomial logic. But as far as estimation is concerned, everything that we said, all the procedures of maximum likelihood estimation kind of extend beautifully and straightforward, right? It's only that the computational burden kind of grows as the number of alternatives increases. Okay, so quickly I wanted to actually demonstrate this using Stata. I see that I have 15 minutes, so let me quickly show that to you, right? Okay. I'm showing this in Stata because I'm comfortable in Stata, but all like your R, Python, all of them today have packages written for binary logit, for multinomial logit, etc. Okay, so here I have an example, right? I have an example where a set of consumers are there and they're making a choice of an automobile. Right, and I have collected this data, right? So what does this first column show? Consumer ID is that, oh, this is the first customer, this is the second customer, this is the third customer, right? And these are the choices that the customer has, right? The customer can buy a American car, European car, Japanese car, Korean car, etc., right? And this purchase, this column shows me what they have finally ended up purchasing, because I'm observing what they have done, right? So in this case, in the first case, consumer one has actually gone ahead and purchased American car, right? And then in the next set of columns, I have some, I have some specific individual specific variables, right? I have the gender. I see whether this consumer is a male or a female. I have the income in, I don't know, thousands of rupees. And then I have the dealers, right? So what does dealer show? Dealer shows how many dealerships are there in the vicinity of the consumer or in the city that the consumer is residing, right? So gender and income are individual specific variables, right? And a dealership is an alternate specific variable, right? It says that there are 9 dealers of American car for the consumer, for the in the place where the consumer ID 1 resides. There are 11 Japanese dealerships. There are 5 European dealerships and 1 Korean dealership. Okay, and I want to explore this relationship between the choice of the car to the consumer's gender, income, number of dealerships that are there, and all of that. Okay, so let us go ahead and so the model that we just now discussed, right, the multinomial logic model or the McFadden model as it is called, there is a function which I can directly apply. So all that it is saying is, all I'm telling the model is that this is the choice that is made, right? This purchase indicates 1001. So this is the choice that is made. Then I'm saying what are the variables that I'm interested in, or what are the attributes that I'm interested in. So this is the dealer attribute. Then I'm saying at what level is the data, the consumer ID level, right? Because there are 4 such observations for one consumer on what he is or she is purchasing. Then I'm saying where are the alternatives given? So alternatives are given in the column heading car. And then I'm saying what are the individual specific variables or the case variables, which is gender and income, right? And then when I run that, I get these. See, it has run this, right? It is doing the likelihood. It is doing, and in 4 iterations, it has kind of converged, and then it is giving me these results. So what is it? What is this result saying? So all it is saying is, for instance, if I look at dealership, It is saying as the number of dealership of a particular car make in the community increases, the likelihood of purchasing that car increases, right? And when I look at individual specific variables, what is it telling me? It is telling me that if you look at gender, for instance, it says that men are less likely, this is a negative sign, men are less likely to pick a Japanese car over an American car than women, but they're more likely to pick a European car and a Korean car, right? Or if you look at income, it's saying that raising the person's income increases the likelihood that he or she purchases a Japanese or a European car, but decreases the likelihood of purchasing a Korean car, for instance, right? Because this is negative, right? You could also, so the command is quite strong in the sense that you could also specify in terms of odds ratio, just like you do in any logistical regression setup. You could actually specify in terms of odds ratio, etc. And you could also predict, right? So for instance, for a moment, imagine that I only had data on 500 consumers, and then let us say I ran this regression on, I ran this multinomial logit on 500 consumers, and then I wanted to, and later I went ahead and collected more data, not the choice, only the data on attributes on the rest of the consumers. And if I wanted to predict their probability, I could actually do that as well, right? So if you look at this, until 500 consumers, what have I done? I have actually collected the data and used them to find what my betas are, right? And for the rest of them, I have predicted it, right? So what is it telling me? It's telling me that, oh, based on the parameters and based on these values you have given me, this customer number 501, these are the probabilities, right? So with probability 0.42, he would purchase an American car. With probability 0.33, he would purchase a Japanese car, European car, and Korean car. Right. So I mean, this was just to show you a glimpse that all that we discussed is actually already programmed. These are all available in most of the software packages that we use, which is R and Stata or Python, etc. Right. Okay. Let's come back because we have one last but important thing to talk about.
Ma'am, once you have run that thing and you have got a test data that you have run this particular multinomial logic and have given a certain output on that, and then you have got a kind of a data on which you are working on a separate kind of a data, and you are saying this is the probability that it's given this kinds of data and the analysis that I have done, this is the probability of choosing this car or that car. How do we test the robustness of this particular model, that it is actually giving the how robust it is? How do I make a choice of that?
Yeah, so I didn't go into that for paucity of time, but just like in a regression setup, you have the notion of R square, adjusted R square, right? Which tells you how your model is, how well your model is able to predict, or how good your model fitness is. So there are fitness parameters even for the fitness measures for your multinomial logit as well. So we are not going into that for lack of time here, but there are the fitness parameters which you could look at, which can tell you how good your model is. Does that answer your question, Dibyendu?
Yeah.
Madam, I am having one question that you are actually predicting the probabilities. So how to interpret that probability? Suppose one probability is 0.42 and another is 0.9.
Yeah.
And another thing is that based on the data, basically where to set this particular cutoff probability. Basically, a cutoff probability is equal to means you have to basically come back to the original ranking, right? Means whether ranking or
exactly
whatever.
So those probabilities add up to 1, right? So you could say whichever is the greatest probability. Okay, I would look at that as the ordering in terms of the person choosing.
But the thing is that suppose 0.42 or suppose 0.58, should I consider it as class 1 or class 2 or class 3? That kind of thing I am asking.
Sorry, I don't understand your question. What do you mean by class?
Class means that you have basically taking the rank, or basically suppose car make choice. Okay. So suppose Tata, Suzuki, Maruti Suzuki, and this thing. So by 1, what are you making? That is it Tata, is it Maruti, or is it Hyundai?
So it's the probability, right? So you could see that one has the highest probability.
Okay, so can you please show me
Yeah,
that?
for instance, if you look at this, you see that the probability to buy an American car is 0.42. The probability of buying a Japanese car is 0.33. European is 0.1 and Korean is 0.06. So you already have a natural ordering there, right?
Okay, acha. So you are already having that data with you. That
this probabilities would add up to 1 in this case, and then we'll be actually having this highest probability is the is the dominance where this person would go for that car.
Is
Thank
that
you.
okay?
Yes.
So now that we have looked at the logit model, so there are some properties of this model which we have to be cognizant about, right? And these properties, they came about because of the assumptions that we made, about the error distribution, etc. These things came about. Now, why are we interested in this substitution pattern, right? So let us say one option somehow gets better, right? So if one option gets better, like for instance, let's say the price of an option goes down, right? If you're thinking of the 3-car example, let's say the price of one goes down, then the chance that that option will be chosen goes up, right? So some people who would have chosen other options based on the original criteria now choose the new option instead. But since all probabilities add up to 1, increasing the likelihood of one option, what does it mean? It actually means that I'm decreasing the likelihood of other options, right? In some way, I am taking probabilities out of that and giving it to this other option which has gotten better, right? So it implies a reduction in probability of the other alternatives. And this pattern of substitution among these alternatives actually has very important implications and very important consequences in the in our model. And this logit model, the way it assumes the substitutions, actually results in something called, it's manifested in something called a independence of irrelevant alternatives. We look at what that is. Right. So what am I saying? For any to look at two alternatives, I and K, right? So if I actually look at Pin by P and K, if you remember, what did we have? We had e to the power Vn divided by summation of e to the power Vn j going from all alternatives, divided by e to the power Vnk summation of e to the power Vnj. So this and this actually gets cancelled, and what you end up getting is this. Right? And what is this showing? This is actually showing you that this ratio does not depend on any alternatives other than I and K. Right? So for any two alternatives I and K, the relative odds of choosing I over K are always the same, no matter what other alternatives are available or what are the attributes of that alternatives. And this ratio is actually independent from the alternatives other than I and K, right? And this is defined as the independence from irrelevant alternatives. So put very simply, all it is saying is that for a specific individual, the ratio of the choice probabilities of any two alternatives is entirely unaffected by the other alternatives or the attributes of alternatives. Right? Now it might seem, okay, sure, this is what it is telling us, right? It might seem very innocent, but if you actually look at what is happening, let us while in some situations this could be okay, right? This assumption of IIA could be an accurate representation of what the reality is, but in some situations it can actually get us in trouble. And this is so there is an example. There is something called the red bus blue bus paradox, which shows how if IIA is not realistic in some situations, then how inappropriate it could be in terms of our conclusions, right? So let us take this, it's a made up example to make a point, right? So let us say that there are two modes only, okay, bus and car. And to begin with, we know that the probability of taking a car is half, and let us say these buses are blue in color, right? And the probability of taking a blue bus is half. So let us say this is to begin with, this is what we observe. So what is happening to the ratio of these probabilities? Probability of taking a car and probability of taking divided by this is half by half, which is 1. Now, let us say after a few days, a new red bus is introduced, which the commuter or the traveler can consider to travel in. Now, this red bus is exactly similar to the blue bus in terms of all the attributes, except that it is red in color, right? It's all the same with respect to the blue bus, all the attributes that it has. Now, the probability that the traveler or the commuter will take the red bus should actually be same as the blue bus, right? Because they have the same attributes, etc. But in the logit model, what did we see? The way because of the assumptions that we make, it results in this irrelevant IIA property, right? So which means what happens? This ratio has to remain the same irrespective of whatever another alternative is there or not. And for this ratio to hold, right, the only probabilities that satisfy this ratio are if later car and blue bus and the red bus all becomes 1/3, because only then your PC by PB or the blue bus, the car by blue bus will remain 1. So your logit will actually predict the probabilities as 1/3. But in real life, you would actually, what would you expect? You would expect that the probability of taking a car should remain the same, right? Because when a new bus is introduced, which is exactly like the old bus, we would expect the original probability of taking the bus to split, right? So we would actually expect the car to remain the same, and we would expect blue bus and red bus to actually become 1/4. Right? So what is happening? I mean, what are the repercussions? So the logit model, because of the IIA property, is actually overestimating the probability of taking either of the buses and underestimates the probability of taking a car, right? When it does the 1/3 thing. So of course, this example is a stark example, right, and unlikely to be encountered in the real world. But this kind of prediction can actually arise with logit models whenever the ratio of probabilities for two alternatives changes with the introduction of new alternatives, right? So, for example, suppose a new transit mode, right, is added, which is similar to existing models like an express bus along with the already standard bus service. So the new bus might be expected to reduce the probability of a regular bus by a greater proportion than by the probability of car, and the logit model can wrongly predict demand for the two buses in this situation, right? So of course there is also a test for this IIA in empirical terms, right? You don't have to worry about it. So there is something called a Hausman-McFadden test. In fact, the intuition for this test is very simple, right? So all it does is, what are we saying? If new alternatives are introduced, if the ratio should not change, right? So all that this test does is that it takes a subset of the alternatives, and then it estimates the parameters, and then it also estimates the parameters for a full set, and it sees if the difference is significant, statistically significant, etc. So in empirical terms, you can actually test for this IIA assumption. But you should always remember that when you are using a multinomial logit model or a binomial logit model, the way or the assumptions that go into the model, the way we have defined it, manifests as this independence of irrelevant alternatives assumption. Okay. There is one more way in which it is manifested. For want of time, I will skip that. But it is related to this. It's proportional substitution. It's related to the example that we saw, but a much more real life example. So there is a reason why this workshop was called Introduction to Discrete Choice Models. It was not for lack of creativity that, okay, what do I call it? Introduction to Discrete Choice Model. No, I mean, we have indeed just scratched the surface, right? We have not looked at many things. We have not looked at alternatives to logit models, though I mentioned that briefly, right? I said, oh, if you make the uniform distribution for the errors, it leads to something called a linear probability model. If you make the normal distribution for errors, it leads to something called the probit model, right? We didn't look at that in detail. And there are also extensions to this multinomial logit model, right? For instance, I did not talk to you about, we said betas, right? I said that, okay, let us say beta 1 gives you what is the taste preference for travel time. now you could argue that, oh no, Maya, for college goers, this beta is different. For office goers, this beta is different, right? So which means what? This beta 1 could actually be different betas depending on different customer segments that we are looking at, right? So there are different extensions to an MNL called the mixed logic model, which could actually incorporate this, right? Or this IIA assumption. I told you how to test for IIA assumption, but what if it so happens that IIA assumption does not hold in your empirical case? Then there are models called the nested logic models, which can actually relax this IIA assumptions and relax the substitution patterns, and which are extensions of the nested logic model. We also did not talk in detail. I just showed you an example in Stata, but we didn't talk about in detail about how to gather the data, how do we structure it, etc. Right? And also we didn't talk about one important thing, which is the endogeneity, right? Which you would have done in your regression setup, where you say that, oh, what if right now what we have assumed that all the explanatory variables that are going into my discrete choice model are independent of the observed factors, right? But it could be that your explanatory variables are endogenous, they're correlated with your unobserved factors, just like in a regression setup. So just like you have methods to take care of endogeneity, like your instrument variable approach, etc., or the fixed effects model, etc., here as well you have different methods of handling endogeneity, like a control function approach and all. So we have not dealt with all of that, right? So the hope is that this introduction to discrete choice modeling kind of will make you think about choice scenarios more carefully, and perhaps serve as a primer to help you ease into other complex models which build on the logit model, but use similar thinking and similar machinery, and can be used to explain choice behavior by estimating preferences, by predicting choice behavior, depending on the need, depending on your research question, etc. Right. So Sandeepan is asking what is the textbook. So it is in the research, it's in the reference slide as well. So the book by Ben Akiva and Lerman is, at least I can think of, is one of the best books. Then there is book by Kenneth Train. In fact, Kenneth Train has written, I think, 3 books and multiple papers as well. So you could look at Kenneth Train's books. So all from my side. I'm sorry I took 10 minutes more of time, but I would attribute that to the technical difficulties. So I think I could take that liberty. But thank you again. I mean, on a Friday evening, you have all joined. So I am happy to take questions, if any, but if there are others who want to kind of leave.
Ma'am, just one, maybe, we are all, maybe the others also are coming a little late for this thing, maybe. But you explained at the end that in terms of IIA, where you talked about, yes, it's like the alternatives that you are having, it's not really making any kind of impact on that. That's what you were saying. It remains the same, half and half, it cancels out and it becomes one. I have just a question, and that's just in the pure form of understanding I'm asking this question. If I'm having a red bus, I'm having a blue bus, and I am introducing a red express bus. Okay, so that's one that is we are introducing. So if I'm a red bus company, I believe that I was losing to my competition. Blue bus had more number of customers. Now in order to get more customers, I have actually introduced a red express bus. In that way, probably by introducing that, I am getting some additional customers. Definitely that is happening. But in the long run, what is happening is that these red bus customers who have been there are actually getting shifted to this, the red express bus.
But why
in this way? In the sense I am saying is that I am only cannibalizing my the product that I'm having, and probably not having got the more number of customers that we are thinking of getting from the blue buses. Can it happen like that?
No, it can certainly happen, which is why when we say IIA, it does not mean that it is a wrong thing. The reason that I gave that Stark example was to show that because of this assumption, in this case, where I hypothetically defined a red bus which was equivalent to blue bus in all aspects, just painted red, I hypothetically defined that to show that in this case, the assumption will not hold. But there are many cases where multinomial logit is used, where, like the example that you gave, IIA holds, which is why there is an empirical test as well. So there is a contextual angle, like you said, where you can see that, oh, okay, it makes sense to have this restrictive assumption. And you can also test that assumption, in which case MNL is the correct model to kind of use. And you will see that also, like when you read research papers, it's not that MNL is this theoretical model which nobody uses. No, they are used for a lot of applications, predictions, etc. I just gave this example, which was like an extreme example to make that point. That's all. Okay. Sorry, I mean, I think I rushed to the end because of lack of time. So I hope that point is clear now.
Yeah.
Madam, one last point. What is the full form of this IIA? Is it same as IID?
No, it's independence to irrelevant alternatives, because it's only
okay.
So it's like other irrelevant alternatives.
Okay. Thank you.
Yeah, thank you again. Thank you, everyone.
Thank you, ma'am, for the wonderful session.
Oh, I'm glad, even if some of you find it useful, that would be nice.